now that we've discussed electron configurations of atoms, we can talk about electron configurations of ions. And remember, an ion is very similar to an atom, except it's going to vary with the number of electrons that it has. So if we look at sodium and compare that to the electron configuration that we would have to write for sodium plus, or the sodium plus cation, we need to remove one electron when we go from the sodium atom to the sodium plus cation. So now our electron configuration becomes 1s2, 2s2, 2p6. If we look at magnesium, magnesium's common oxidation state is 2+. So when we write the electron configuration for magnesium 2+, it's going to be the same as magnesium, except we need to remove 2 electrons. So this is going to be 1s2, 2s2, 2p6. For aluminum, aluminum's oxidation state is 3+, so we need to remove 3 electrons. So that's going to give us an electron configuration of 1s2, 2s2, 2p6. Notice that for both sodium plus, magnesium 2+, and aluminum 3+, our electron configurations are all going to be 1s2, 2s2, 2p6, which is the neon noble gas core. And remember, the noble gas electron configurations are very stable. And this is actually why sodium wants to be a +1 charge, magnesium a +2, and aluminum a +3, because they will exist as the noble gas configuration, which would be, in this case, neon. It's a very stable arrangement, and all of the quantum mechanics theories that we looked at all show that electrons want to exist in the most stable arrangement possible. So now let's look at some anions, and the difference between fluorine and the F- anion is we need to add an electron. So now our electron configuration becomes 1s2, 2s2, 2p6 instead of 2p5. The same thing for nitrogen. Notice that nitrogen, when it becomes an anion, needs 3 more electrons to get to that noble gas core. So it's going to be 1s2, 2s2, 2p6. So again, the F- and the N3- electron configurations also have the neon noble gas core. And in addition, these are very stable. So this is why the fluorine anion wants to gain 1 electron, and the nitrogen anion needs 3 electrons. It's because they want to reach that stable arrangement or that noble gas core of electrons.